For day 3, we kind of backtrack in the book to chapter 9, section 1, which in my opinion is one of the what pattern we're dealing with. Hard to know well when we're using formulas. You get to number 6 and 7 where we're writing a formula and writing a formula, whether it's recursive. Those problems um, and homework error until you come up. But the first part is straightforward. Number 1, find the first 5 terms of each, which is literally to find the first term, put a 1 here and a 1 there. So 2 times 1 squared plus 1. The first term is 2 times 1 plus 1. The first term is 3. The second term, put a 2 where the n is. So 2 times 2 squared plus 1 turns 9. Second term is 9, and so forth. 3, then a 4. So 2 times 3 squared plus 1. 2 times 4 squared plus 1, and then 2 times 5 squared plus 1. So you build 5 terms, and you get 3, then 9. 2 times 3 plus 1 would be 19. And then 2 times squared, 2 times 16, and then 20, 51. So that's a list. 2, same thing. Plug in a 1, then a 2, then a 3, then a 4. This, 1 half, 2 over 2, 3 over 2, 4 over 2, and then 5 over 2, which you want to reduce these two because they're not, 2 over 2 is the number 1. So 1 half, comma, 1, comma, 3 halves, comma, 2, and then 5 halves. So again, you fill up straightforward 5 terms of each sequence, and that's an explicit formula because it involves n. Next problems 3, 4, and 5 are recursive. So recursive tells you this term and do something to it. I'll read it aloud. It's been a while since you've seen the symbols. And it's saying, number 3, a sub n, any term equals the previous term 5. So when you apply that, they tell us the first term is 10. So the second term that we're about to find next is equal. The second term is equal to the first term plus 5. So you'll take your 10 and add 5, and your second term is 15. Then when you go to find the third term, again, it's true. Any term is previous plus 5. So you take 15 and add 5 and get 20. And then you start, I'm just adding 5. So 5, 30. The symbols telling you start with 10. A sub 1 is 10. And any term, a sub n, is the previous plus 5. Let's try it again. Number 4. In previous and subtract 3. So we'll start with a 4 and then follow this script. 2 times the previous minus 3. The second term is 2 times the first minus 3. All right, so 2 times the first term. 2 times 4, 8. 3 is 5. So the second term. And we'll use the formula again. Third term. A sub 3 equals 2 times the second term minus 3. Any term is the previous term times 2 minus 3. So take our 5, our second term, and double 10. Subtract 3. So go and double it and subtract 3. Double the 7, 14, 11. One more time, double that term 11, 22, and subtract 3, 19. And then more, pause the video here and try it, but because it has the n, you may not feel comfortable. 1 second. Just so the first term is 10, but then it says plus n. All right, so I'm going to put n equals 2 because I'm finding the term. If I find the second term, it will equal the first term plus, notice that the 2, so when I represent n in the formula, it's a 2. Take the first, add 2. So 2 and use 3 for n. To find the a sub 3, take the a sub 3 minus 1, a sub 2, take the second term, and add, so you'll use 3 for n. Take your second term and 3. So add 3, you get 15. To find the n equals 4, a sub 4 minus 1 would be 3, and n, so we'll use 4 right there. So it's telling us to find the fourth term, take the third and add the 15 and add 4. And add 3, then adding 4. On the fifth term, just add 5, 24. Recursive pattern. A recursive pattern takes the previous term and does something to it to get the next one. Let's scan down here. Okay, I'm actually going to skip 6, 7, 8, and 11 and 12. And depending on the time on the video, I may stop. But number 11, evaluate each. Find the sum of this formula starting with 1, stopping with 5. In number 12, we're going to use this formula. Start with 4, stop at 7. So chug, quickest way to evaluate these. 11, 1 squared plus 1, putting the 1 in for n. Then a 2 squared plus 1. Then a 3 squared plus 1. And then a 4 squared plus 1. And then stop at 5. So plug in 5 squared plus 1. Find all those numbers are 2, 5, 10, 17, and 26, and then add them all up. And we will get a sum of 90. Number 12 is exactly the same. It's just going to be a fraction answer. Plug in a 4, 5, 6, and stop at 6. So 4 over 3 plus 1. Then plug in a 5 over 3 plus 1. Then plug in a 6 over 3 plus 1. And then a 7 over 3 plus 1. Notice the 4, the 5, the 6, and the 7, and plug them in. Take those calculator, 7/3. The second number gives you 8/3. The third one gives you 9/3. 3. And then the last term there will be third. All right. In fact, I think that this will be what to try number 15 on your mind. Then I'll get a separate, again, the writing the form. That'll be the most difficult homework, and take several minutes for one question because you're just trying to pattern that's going on. But try number 12, pause the video, and check. All right, as you see, my work is on the 15's on the board here. And those numbers, 250, 432, and 686. So again, the video is getting minutes, so I'll go ahead and start here, and then I'll finish with a separate how to do the writing of form.